Alright, so today we're going to learn a little bit more about speed equals distance to time, over time, and how that can be useful. So let's take a look at this question. If you drive 60 miles in 1 hour, what was your speed? Mr. Boykin?
60 miles in 1 hour. Ooh, that'd be like 60 miles per hour.
Yeah, okay. Uh-oh. All right.
I think he's going 60 miles per hour.
If you drive at 60 miles per hour for 2 hours, how far will you go?
60 miles per hour. That means in 1 hour you're going to go 60 miles. So in 2 hours, that'd be 120 miles.
Exactly. How did you do that?
I multiplied. I think I multiplied.
Okay, yeah, 60 times 2 gave you 120. All right, so equations show the relationship between things.
Okay.
And here is an equation that shows the relationship between distance and time. If we wanted to solve for d, how will we do this?
I know.
Let's take a look. All right, we are not going to use speed equals distance over time yet. We're going to use some different variables. So, how would we solve this for y? How will we do this? The first thing we want to do is get y by itself. So we have to get rid of z. If we have division here, we have to do the opposite of division. The opposite of division is multiplication. If I do one thing on this side, I have to do the exact same thing on this side. So I'm going to say times z. But we're not done over here yet. These two things, because we have the same thing on the top and the bottom, we can cancel them. So cancel, cancel. So now I'm left with y equals z times x. So y equals z times x.
Numbers.
Boom, I'm happy. All right, so can we check our work here? So what if I said over here, I'm gonna write it, I'll write it next to it over here. What if x was 6 and this equaled 3/2? All right, so now we're gonna play. Our goal here is going to be to measure our walking speed and use it to measure distance. The first thing that we are going to do is measure our walking speed. Now, I want to bring your attention over here real quick. The goal here is to measure our distance using our walking speed. Let's look here. Measure our distance using our walking speed. So first we have to find this. We're going to go outside and measure our normal walking speed the same way we measured our speed in the previous lab. Then, we also have to figure out time. Once we've got speed, we need time to calculate distance. So that's where this part comes in. We're gonna hop out into the quad, whoop whoop. And what we are gonna do is we are going to choose 3 different line segments. So maybe A to B, A to J, J to G, whatever you want, 3 of them. Or whatever we want, okay, 3 of them. And we are going to measure how much time it takes us to go from A to B, or A to J, or J to G, okay? So the goal here in the second step is to measure how much time it takes us to go a certain distance.
Cool. Let's grab a stopwatch.
Sweet, let's do it. All right, you guys, I'm out here, gonna measure my speed. I'm gonna go 10 meters. So I went 6.14 seconds. I'm just gonna write down the numbers here. Strength. So T equals 6.14 seconds. And my distance I said was 10 meters.
Sweet.
I'm not gonna do the math now. I will save that for later. All right, Mr. Boykin, let's see if we can figure out this map.
North is that way.
Yes. And our classroom is, we're kind of right in this area. That's
Actually,
the
right
Golden
now,
Valley.
this is,
Oh.
we're at A.
Oh, you're right. We're totally over here. Okay. So, what do you think we should do for our first one? Maybe you said maybe A to B or something? Let's keep it short, right?
Sure.
Okay, so I'm going to go ahead and start A. A's over here. And it looks like B is in that next opening. Over
I'll
there.
go stand where B is.
Okay, great. I'll get the timer ready.
Right here.
All right. So A to B. Let's do it, baby. Time. 8.84. 8.84. Beep.
A to B.
So A to B, and that was 8.84 seconds.
Now where should we
Sweet.
go?
All right, let's spice it up here.
Let's go towards the cougar.
I agree with that.
Hold on. You
Oh.
start.
Oh, you mean start here?
Yeah. So,
Okay,
what segment would that
let's
be?
go B to J.
All right.
All right, and go. Oh, pause. Forgot to reset it. Take 2, and go. This is the speed I go when I'm trying to hustle and make copies. And time. 15.81. That was 15.81 seconds.
Sweet.
All right. All right.
Now where?
Want to go to L? It's kind of in the way of those benches over there.
No, I think we can get around it.
Yeah? Straight shot to the corner?
I think so.
Okay, sweet. Let me get started. Let me reset first. Here we go. And go.
Oh, this is so much fun I can hardly stand it.
Good call on the shade too. 12.29 seconds. Okay. 12.29 seconds, and that was from J to L. I should have done JK. Okay. All right, sweet.
Let's go back in the classroom.
Back to the classroom, here we go. All right, so here we are with our data. Now the first thing I'm gonna do is calculate my speed. And don't forget, speed equals distance over time. So my distance was 10 meters divided by 6.14 seconds. 10 divided by, and you have to sing as you type it into the calculator. And I get my speed is we're gonna call it 63 meters per second. Don't forget your units. Now that we have our speed, we can figure out our distance. How, Miss Moore, how do we do this? Well, we know that our equation is distance equals speed times time, d equals s times t.
But it says T times S, Miss Moore.
Ah,
Can you do that?
yeah, you can totally do that. So, you know, we're just basically flipping the way that it is. We still, if you wanted to check it, you could try checking it, you know, with 6 equals 3 times 2. And then if you put it on the other side and said 6 equals 3 times 2, do we get the same thing? Yes,
You get
we
the
do.
same thing.
Same thing, we're good here, okay? So I'm gonna do the first one with you guys, and you guys are gonna finish off the last 2. All right, so we're trying to figure out the distance here. Distance equals our speed is from up here, 1.63 meters per second, and our time is 8.84 seconds. This is nice because our units cancel here and we're left with meters, which is totally our units for distance. Excellent, I'll put that here. Now I'm gonna do my math. 1.63 times 8.84. 1.63 times 8.84. And I get 14.41, all right? I'll just box it for you guys. It's, kind of all over the place, but that's my distance for this first segment. As we go from A to B, I used my speed that I calculated before and the time it took me to walk that to figure out what the distance from A to B was. Again, you guys do 2 and 3.
Hey, Miss Moore, I've got an idea. Let's use that round clicking thingy and measure how far it is actually.
The trundle wheel.
I'll go get it.
All right, I'm gonna go ahead and measure the distance from A to B with my handy dandy trundle wheel.
Woohoo!
Exciting stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, it makes sense because it was like 14.41.
Yeah.
All right, sweet. All right, let's come back to this 60 mile per hour thing. If you drive at 60 miles per hour, how long will it take you to go 120 miles? Mr. Boykin?
How long? Let's see. That's time, isn't it? Let's see. Well, wait a minute. That sounds like that one we did before, and I know it should be 2 hours because 120 miles at 60 miles in 1 hour ought to be 2. How do we do that?
How do we do this? I'm glad you asked. Let's take a look at this equation. So the question was asking how long will it take you? So we're talking about time here. So we're gonna figure out how to solve this for time. Before we do this, let's practice with some other variables. Let's say A equals B over C. And we wanna get this guy by himself, okay? Well, before we multiplied by C on both sides, and we multiply because it's the opposite of divide. And if we do something on this side, we have to do it on this side. These cancel out. Boom. We do not have C by itself though yet, do we, Mr. Boykin?
No,
So we have to get rid of A on this side. How do we do this? Well, we've got multiplication here. Opposite of multiplication is division. Over here, we just divide by. We have something the same on the top and the bottom. What can we do? We cancel them.
There you go.
Okay. So that was a lot of work. Let's talk about an easier way to do this. Let's say we have 3 equals 6 divided by 2. This is true, yes?
Yep.
6 divided by 2 equals 3. Okay.
Oh, you're going to do the same thing you did a minute ago.
Yeah. So again, we want to try and get the 2 by itself. Wait, pause it. I'm going to multiply by 2 over here because it's the opposite of division.
That's what you did before.
Yeah, multiply by 2 over here because you have to do the same thing on both sides just like I did before. These guys cancel. 2 times 3 gives me 6, yes?
Yes.
Okay, sweet. Okay, so the next thing I'm going to do, I've got to get 2 by itself. The opposite of multiplication is division. So in order to get rid of the 3, I'm going to divide by 3. Okay, I'm going to divide by 3 over here. And now I've got 2 equals 6 divided by 3. Is this true?
It's the same thing you did before.
Very, very true.
And
Same
you forgot to cancel the 3's before.
Oh my God. Don't be like me. Cancel your 3's. Okay? All right, so, okay, I'm going to go ahead and write the original equation up here. So the original equation is A equals B over C. So you know what I noticed the difference between these two equations is? The A and the C are just flipped. The A and the C are just flipped here. So, what you can remember to do, instead of doing all this work, if you're trying to solve that variable at the bottom, I just flip them, okay? I just flip them. What does that mean? Well, I'm gonna go ahead and flip. I'm gonna put the A down here and the C up here.
Does that work with the numbers?
You bet it does. So I'm gonna go ahead and try it out. Let's see, so before we said 3 equals 6 divided by 2. I'm gonna go ahead and flip these two numbers. I'm gonna say 2 equals 6 divided by 3.
Correctamundo.
And we're done. So we come back over here. We take what we learned, the easy flip. as Boykin calls it, the Boykin flip. And we're just gonna go ahead and flip these two letters. So we're gonna put T equals D over S. That's how we solve for T. And so coming back to our question up here, and you said, Boykin, how do we do this? Well, let's plug in some numbers. So if you drive at 60 miles per hour, that's our speed. How long will it take you to go 120 miles? Okay, I plug this into my calculator. Well, 120 divided by 60, I get 2. And I know that my units for time is hours.
Boom, done.
Do you think I need to explain the units? All right, so let's regroup here. So before I ask you any of these questions, I want to point you to the objective here. Our goal here was to measure our walking speed and use it to measure distance. So my first question, what did you do on the sidewalk and why? So on the sidewalk, we basically measured our normal walking speed. And why did we do this first? Well, don't forget, our goal here was to measure our walking speed down here in order to measure our distance. Okay, so the next thing we did was we went and walked in the quad. What did we do in the quad and why? Well, we chose 3 different segments and we walked from one of those segments to another. We walked from here to here, from there to there, and then from there to there. So that's what we did. And during that time, I also used the timer to measure how much time it took me to do that. Why did I do this? Well, the goal here is to measure our distance. And in order to measure distance, we need speed, which we calculated up here, and our time, which we measured right here. So we needed the time in order to calculate the distance. So what calculations did we make overall? Well, we calculated our speed, our normal walking speed, and then we ultimately calculated our distance using the time it took us to walk in that speed.
Sweet.
All right, so here is our definition of speed. Speed equals distance over time. There's a relationship here. And this relationship can be expressed in 3 different ways. We can try and solve for speed, we can move things around to solve for distance, and we can move things around to solve for time. Now, to figure out which equation you need to use, you need to read the question and information mine and figure out what variables do you have and what are you trying to find out. So that's the first thing you have to do. You always have to read through the question, information mine, and figure out what are you trying to find out, what do you have. Then you can pick which equation you want to use or you need to use. So let's go ahead and take a look at some questions. A high school athlete runs 100 meters in 12.2 seconds. What is the speed? Let's start by information mining, writing down the numbers in units. Here we have 100 meters. And I also see 12.20 seconds. I see the word speed, so I'm going to say S equals, that's a question mark. What is the speed? I'm going to put that right there. Now, I want to label these 2 variables. Meters, that must be distance, and seconds, that must be time. So I'm trying to find speed. And if I look back up here on my equations, my options for my equations, I'm going to go ahead and choose this one. Speed equals distance over time. Speed equals distance over time. So my distance was 100 meters. My time, 12.20 seconds. If I plug that into my calculator, I get 100 divided by 12.20, and I get, I'm gonna call it 8.20 meters divided by seconds.
Sweet.
Sweet. All right, so I'm gonna put that over here. All right, the next one, I'm gonna do the first part with you guys, and you guys are gonna do the second part later. And it says, a car travels a constant 11 meters per second. How far will it go in 25 seconds? I'm gonna write my work up here. So I see 11 meters per second. I see 25 seconds. I see how far. That must mean distance. All right, I know speed is meters per second. I know t is seconds. I'm trying to find distance, so that means I'm going to use this equation. D equals S times t. So D equals S times t. I'm going to plug in my numbers here. Speed is 11 meters per second, and my time is 25 seconds. I'm going to cancel these S's because they're the same on the top and the bottom. Cancel, cancel. I'm left with meters. That's perfect because distance is in meters. And I'm going to go ahead and do, and I don't want this to confuse you guys. This is a multiplication. That's not a decimal. So 11 times 25, and I get 275, and my units were meters. I'm going to have you guys answer this question later. I'm going to put it aside. Okay, I'll show you guys this at the end. The next one, this is the last one I'm going to do with you guys, and I'm just going to information mine it with you guys. You guys are going to finish off this problem. All right, a train is traveling with a constant velocity of positive 36.0 meters per second. How many seconds will it take to travel a positive 1,620 meters? That's a lot of words. Let's write stuff down. So I see 36.0 meters per second. Should I write that plus sign in there?
Can't hurt.
Yeah, we'll put it in there. Okay. We'll talk about that later. And then all right, so the next thing that I'm gonna write down is this positive 1620.0 meters. And it says how many seconds. We want to know, we're wanting to try to find time. So time equals question mark, and we know that meters is distance. Okay, so we know our speed is 36 meters per second, our distance traveled is this, and our time, we're trying to figure out the time. So again, we know that we get to choose from those three equations. We know that speed equals distance over time. If we're trying to figure out what time is, I can just flip-flop these guys, and I know that time equals distance over speed. And I'm going to go ahead and use this equation down here. Time equals distance over speed. My distance is positive 1620.0 meters. I divide by my speed, which is positive 36.0 meters per second. Okay, let's go ahead and get my answer here. 1620 divided by 36, boom. And I get the lovely answer of 45 seconds. All right. So what you guys are gonna do is you guys are going to answer this question. You are going to answer part B of this question. Now keep in mind, I'm asking you how far will it go in 1.5 minutes, but up here I'm giving you my speed in meters per second. So keep that in mind. How many minutes are in a second? Or in 1.5 minutes, how many seconds are there? And then lastly, you're going to answer this question. What is your walking speed? How would you walk in this much time given this information? All right, and good luck.